So here is the workflow used for the rotor optimization, where the blade loading and stacking parameters are used to generate the blade shape in Turbo Design 1, and then the resulting performance parameters are fed into Turbo Design Optima, which basically applies MOGA to drive the solution towards the optimum design. And of course, we need to start by specifying the range of variation for the input parameters, which are the stream-wise loading parameters and also the trailing edge work coefficient, because it has an influence on the wrap angle and therefore the blade stresses. And in fact, there is a machine learning based feature that can provide initial range estimates for these input parameters, which basically helps to explore a large design space, but also avoids infeasible solutions. And then here are the constraints that are used. So basically, in addition to throat and the overall diffusion ratio, um, we constrain some wrap angle related user defined parameters like the UD wrap, which is basically the wrap angle difference between 15% span and up at the blade trailing edge. And then the UD-RMSE calculates the root mean square error of all the wrap angle differences between these various locations, and which would actually be zero for a perfectly radial fibered blade. And so this is constrained as well. And then UD work is calculated by the volume flow averaged RV theta variation between the leading and trailing edges. And this is related to the turbine power to Euler turbomachinery equation and needs to be constrained as well. And then finally, for the optimization objectives, we want to minimize the profile loss and leaving kinetic energy in order to maximize the efficiency. But at the same time, we also want to minimize some more wrap angle related UDPs, like the UD max deviation, which is the maximum value of all the wrap angle differences used in the calculation of this UD-RMSE before. And then lastly, we want to minimize the maximum bow, which is the maximum deviation from the linear span at 90% of the streamwise location, basically close to the trailing edge, and would be zero again for a perfectly radial filament blade. And so in this way, using these different wrap angle related UDPs, we ensure that the blade integrity is not compromised in the process of improving its aerodynamic performance.